Imagine, if you will, walking into a really high-end professional kitchen right as the Friday night dinner rush is about to begin.
Oh, that is a stressful picture right off the bat.
Right. The tickets are piling up, the servers are shouting, and, well, you need help.
Desperately, yeah.
So you've got two options for getting some assistance here. The first option is a highly competent, incredibly fast digital recipe book.
Okay, like a super-powered search engine.
Exactly. You can ask it, what's the exact ratio of vinegar to egg yolks for a classic béarnaise sauce? Or maybe what's an allergy-safe substitute for tarragon?
And it just gives you the answer instantly.
Instantly. It never forgets. It never stutters. But, and here's the catch, you still have to physically chop the herbs.
Right, you're still doing the work.
Yeah, you have to clarify the butter, you have to stand over the stove whisking those egg yolks and watch the heat to make sure the sauce doesn't break.
So it's just telling you what to do.
Exactly. That is one kind of help. It's advisory. Now, imagine option two.
All right, what's option 2?
Option two is a highly competent digital sous chef. You don't ask it how to make the meal. You just look at it and say, prep the ingredients for table 4, cook the steak to medium rare, make the béarnaise, and plate it.
And it actually does it?
It just does it.
Yeah.
You walk away to manage the dining room, and when you come back, the plate is ready for your final inspection.
I mean, the magnitude of the leap between those two scenarios, it perfectly encapsulates the technological shift we are analyzing today.
It's massive.
Right, it really is. Going from a system you consult to a system you delegate to fundamentally rewires the entire architecture of human work.
Because it's not just about speed anymore.
No, not at all. We're no longer just looking at tools that, help us do our existing tasks faster. We're looking at systems that perform the multi-step execution of those tasks completely autonomously.
Which brings us to the actual mission for today's deep dive. We are unpacking this fascinating piece of research by Jonathan H. Westover, PhD. It's titled The Diffusion of Agentic AI, From Engineers to the Enterprise.
It's a fantastic piece of research, really dense, but so revealing.
Super revealing. We have a massive stack of materials here, backed by large-scale data sets on corporate adoption, historical analogies going all the way back to the Industrial Revolution.
Yeah, the historical context in there is great.
And real-world corporate case studies from some of the biggest companies in the world. We are basically mapping this ongoing shift from what the industry calls conversational AI, which is our digital recipe book, to agentic AI.
A digital sous chef.
Right. And for anyone listening who might be feeling, a bit of AI fatigue lately.
Which is totally understandable. People are overwhelmed.
Totally. Assuming this is just another minor software update or, I don't know, a slightly better autocomplete in your email client.
Right. The data we are about to explore suggests something entirely different. I mean, this is a structural shift in how human labor is supervised, how it is valued, and how organizations operate at a macro level.
It's not just a typing tool.
Exactly. It is the literal difference between increasing your typing speed and completely redefining what it actually means to be a knowledge worker.
Okay, so let's ground this in the terminology Westover uses in the paper, because getting the definitions right is really the only way the rest of this data makes any sense.
Yeah, we have to establish the baseline.
Right. So he draws a very hard line between conversational AI and agentic AI. From my reading of the research, conversational AI, which is the paradigm we've basically all been living in for the past few years, is defined primarily by being synchronous and advisory.
Synchronous meaning it happens in real time, back and forth.
Yes, exactly. It's an information retrieval and content generation mechanism. The user types a prompt, asks a question, and the system responds with text or an image.
Oh.
But the locus of control, the actual execution of the work, it remains entirely with the human.
Right, the human is the engine in that relationship.
Totally.
The AI might provide the blueprint for the house, but you were still the one out there swinging the hammer. The paper notes that in the conversational model, the human user evaluates the AI's draft, they copy the text, they paste it into the final document, they format it, and they hit send.
So much manual copying and pasting.
So much. The AI is trapped inside its chat window. It cannot cross the boundary into your operating system to take independent action.
I always think of it as an incredibly well-read librarian who is locked behind a reference desk.
Oh, that's a great analogy.
Right. Like they can find any piece of information in the entire world and synthesize it for you, but they can't actually write your term paper, format the citations, and hand it to your professor.
You still have to do the physical and digital moving of the information yourself.
Yeah. But now look at how the research defines agentic AI. The interaction model completely flips from synchronous to asynchronous.
Which changes everything.
It really does. And the core capability shifts from advisory to executable. So you are no longer submitting a query, you are delegating a multi-step workflow.
It's the autonomous project manager we were talking about earlier.
Yes. If I'm understanding mechanics detailed in the paper, this means specifying a desired outcome and letting the system operate semi-autonomously across completely different applications.
Right, it's breaking out of the chat window.
Exactly. It's not just generating text anymore. It might open a directory on my computer, inspect a whole batch of PDF files, extract relevant financial data, write a Python script to analyze that data, execute the code, open a web browser to cross-reference the findings against, like, current stock prices, and compile a final presentation.
All while you are sitting in a completely different meeting.
Literally not even at my desk.
That asynchronous nature, that is the critical variable here. Because the system can manipulate artifacts, it can call external tools, and it can even course-correct its own errors without needing you to prompt it at every single tiny step.
It doesn't need its handheld.
Right. It breaks that real-time tether between the human and the machine. You return to the process later to review the output or to handle some kind of exception the AI couldn't resolve, much like a manager reviewing the work of a direct report.
This shift, I mean, it feels like it completely changes the definition of the word adoption in a corporate context.
So absolutely. The paper actually references scholars like Hitzig and Sarkar on this exact point.
Right, because if I'm adopting conversational AI, I don't really have to change my day-to-day routine at all. It just kind of slips into my existing workflow.
You're just adding a tool.
Yeah. If my job is to write market research reports, I still sit down at 9 a.m. and write market research reports. I just have a new tab open on my browser to ask for a good synonym for synergy or to quickly summarize a long article I don't want to read. My job is exactly the same. I'm just slightly better equipped.
You are bolting a new tool onto an old process.
Right.
But Agentic AI, as the research heavily emphasizes, it cannot just be bolted on.
It doesn't fit.
It doesn't.
Yeah.
It forces a fundamental restructuring of the workflow itself. You simply cannot insert an autonomous digital worker into a process without changing how that process is managed.
Because they're doing the work you used to do.
Exactly. If the AI is doing the data extraction, the coding, and the formatting, your role transitions from task execution to workflow design, supervision, and verification.
So for everyone listening right now, this is a perfect moment to visualize your actual Monday morning routine. Think about the specific tasks you do before lunch.
The really tedious ones.
Yeah, the stuff you hate doing. Which of those tasks are you just retrieving information for where conversational AI is perfectly sufficient? And which ones are multi-step, executable administrative loops?
Yeah, the stuff that takes up hours of your day.
Exactly. The ones where you download a CSV file from one software platform, you clean up the formatting in a spreadsheet, you draft a summary email based on that data, attach it as a PDF, and route it to your department head.
That entire sequence.
Yes. Those repetitive multi-application processes are the exact workflows that the research indicates are being handed over to agentic systems right now.
And the disruption inherent in handing over those multi-step processes is massive. Which brings up a very, very logical assumption.
Which is?
Well, if utilizing this technology requires people to completely redesign their daily habits and entirely reconfigure how their departments operate, you would naturally expect the adoption curve to be agonizingly slow.
Because people hate change.
People despise changing how they work. Change management is traditionally the hardest part of any enterprise technology rollout.
Which makes the data provided in this research so striking, because the adoption curve is not slow. At all. It's moving at a blistering pace. But the distribution of that adoption completely upends the traditional narrative of how tech usually spreads. Let's look at the usage statistics the paper lays out.
Yeah, the article provides a really fascinating snapshot here. When looking at individual users over a recent 28-day window, fewer than 1% had utilized agentic tools.
So in the consumer space, or, for solo knowledge workers just tinkering around at home, it's essentially a non-factor. It's basically a niche hobbyist tool.
Exactly. But when the lens shifts to organizational users, meaning people operating within a corporate enterprise structure, that figure leaps up to 17%.
That's a huge jump.
It is. And the data becomes truly staggering when analyzing what the paper terms frontier organizations.
These are the early adopters, right?
Right. These are the companies that have made AI integration a core strategic pillar of their business. In those environments, Agentic tools account for 99% of all AI-generated output.
Wait, 99%?
99%.
So they have effectively abandoned the chatbot model entirely for actual work tasks.
Pretty much. Once the organizational barriers to agentic execution are cleared out of the way, the preference for delegation over consultation becomes absolute. Why ask a bot how to do something when you can just tell the bot to do it?
That makes total sense. But the most revealing data point here, and I think you're citing Johnston et al., from 2026 for this concerns who within these organizations is adopting the technology the fastest.
Right. This is where it gets really interesting.
Because this data point completely subverts what we usually expect. The late adopting, non-technical groups, the legal departments, the finance teams, human resources, they are transitioning to agentic AI significantly faster than the highly tech-savvy software engineering teams did.
Which sounds backward.
It totally sounds backward. My initial reaction reading this was just pure confusion. You would naturally assume the software engineers, the people who literally build these systems, would be sprinting ahead while the lawyers and accountants struggled to catch up and figure out how to log in.
Right. But the paper explains this anomaly through a concept of organizational friction. And it uses a really compelling historical analogy to do it.
Oh, the Steve Power thing. I love this part. It's so good. So to understand why the non-technical departments are moving so fast today, the paper pulls from a landmark 1990 study by economic historian Paul David. He analyzed the transition from steam power to electric power in manufacturing.
Okay, take us back to the Industrial Revolution.
So during the era of steam power, the physical architecture of a factory was entirely dictated by the massive central steam engine. Because power had to be distributed physically through a really complex, rigid system of line shafts, belts, and pulleys, the machines had to be placed close to the power source.
Regardless of what made sense for building the actual product.
Exactly. The logical sequence of the work didn't matter. You just had to be near the belt.
It sounds incredibly dangerous and just completely inflexible. I mean, if you wanted to move a loom or a press to the other side of the room, you couldn't because the physical leather belt wouldn't reach the central steam engine. Right, you were locked into that layout. So when electric dynamos were first introduced, factory owners were thrilled. But they simply removed the central steam engine and replaced it with a single, massive electric motor.
They just swapped the engine?
They just swapped the power source. They left the entire network of dangerous belts and shafts exactly the same.
And I imagine they were incredibly disappointed when their productivity didn't suddenly skyrocket, right?
Totally. The productivity gains they were expecting took decades to materialize. Because the real magic of electricity wasn't just that it was cleaner power, it was that it was distributed power. To actually reap the benefits, factory owners had to realize they could attach a small, independent electric motor to every single machine.
Which changes the whole game.
Exactly. This meant they could finally tear down all those belts and shafts and completely redesign the factory floor based on the logical flow of the work, rather than proximity to a central engine. Economists call this the need for complementary innovations.
Meaning the technology itself isn't enough to change things?
Right. You need a total workflow redesign to unlock its actual value.
Okay, so mapping this historical blueprint onto our current AI transition, the paper is arguing that agentic AI requires those exact same complementary innovations. You can't just drop an autonomous agent into a department that is structured for human sequential work.
It won't work.
You have to redesign the workflow around the concept of delegation. But the remarkable difference here is the timeline. The factory redesign took decades to figure out. The AI workflow redesign is happening in months, and this circles all the way back to why the lawyers are adopting faster than the engineers.
Because the engineers were the first ones to touch the agentic technology.
Right.
And because they were the pioneers, they had to absorb all the friction of building those complementary innovations from scratch. They were the ones who had to figure out how to securely connect the AI to the company's internal databases. They had to navigate the clunky authentication protocols.
Who took all the hits?
They really did. They had to build the guardrails to prevent the agents from executing destructive code by accident.
So the engineers were basically the ones tearing down the steam engine belts and laying the new electrical wiring for the entire company.
That's exactly what they were doing.
To make this concrete for the listener, when the paper talks about building infrastructure and connecting APIs, I always like to think of an API as a digital waiter in a restaurant.
Okay, I like that.
Right. So you are the customer sitting at the table with the menu. That's your software interface. The kitchen is the server where all the data lives. You can't just walk into the kitchen and grab your food yourself.
Yeah.
You need the waiter, the API, to take your specific order, translate it to the kitchen and bring the exact right data back to your table.
Right.
The engineers had to teach the AI agents how to talk to all these different digital waiters securely.
And that infrastructure development is incredibly costly in terms of time, trial and error, and just pure frustration. The engineers bore the absolute brunt of that organizational friction. They suffered through the agents hallucinating, breaking the code base, failing authentication checks over and over.
But once those foundational capabilities were finally established,
And the pipes were laid, so to speak.
the environment completely changed.
It did. The non-technical departments could just turn on the faucet.
Wow.
Exactly. The legal and HR professionals didn't have to spend 6 months figuring out how to grant an AI secure access to the company's secure cloud storage. The engineering team had already solved that problem and standardized the API integration for them.
So a lawyer could walk in on a Monday morning, be granted access to a legally compliant agentic workspace, and just immediately start delegating contract reviews.
From day one, they transitioned from zero usage to majority adoption in a matter of weeks because the invisible infrastructure was already there to support them.
So if you're a listener in a non-technical role right now, say marketing or operations, and you feel like these advanced AI capabilities were suddenly dropped into your lap out of nowhere,
It's an illusion.
right, it's likely because your IT and engineering teams spent the last 3 quarters silently paving the road that you are now driving on. The infrastructure enables the speed.
It does.
But, and this is a big but, that brings us to the next major section of the research, which asks a rather uncomfortable question, frankly.
Yeah, the productivity question.
Exactly. Does this rapid adoption and the ability to delegate all this work actually translate to a more effective organization? Or are we just building extremely efficient engines for generating corporate noise?
That is the million-dollar question.
Because if I have a digital sous chef prepping 100 meals an hour, but my dining room only has 10 tables, we don't have a productivity miracle. We have a massive, wasteful pileup of rotting food in the kitchen.
That phenomenon is central to this research.
Yeah.
And the initial numbers regarding output gains in these frontier organizations, they are truly staggering. The paper cites Johnston et al.'s 2026 data, which tracks median workers increasing their AI-generated output by 10 to 50 times within just a 7-month period.
Wait, a 50-fold increase in output.
50 times.
That is difficult to even conceptualize. The data shows legal professionals increasing output 13-fold and research roles showing over 50-fold growth. I mean, if I'm a financial analyst and I go from producing 1 deep dive market report a week to producing 50 reports a week.
On paper, you look amazing.
Right. On paper, I look like the most productive employee in the history of the firm.
But your restaurant analogy highlights the exact flaw in that metric. The research by economists Demeurer et al., which Westover integrates here, explicitly warns that task-level productivity does not automatically equal organizational performance.
Because the bottleneck just moves.
Precisely. If the agentic AI completely unblocks the task execution phase, meaning the actual typing, the data gathering, and the drafting of those 50 reports, and just shifts all that pressure further down the line. And according to the research, the new bottleneck is entirely human.
Right. The downstream human activities are the new constraints on corporate velocity. It's review, integration, strategic decision-making, and cross-departmental coordination.
An AI can generate 50 comprehensive research reports by Tuesday morning. But a human manager still has to actually sit down and read them.
And reading takes time.
A lot of time. A human has to evaluate their accuracy. They have to determine which insights are actually relevant to the company's current quarter. They have to integrate those findings into a coherent strategy and then convince the executive board to act on them.
So if the human review process doesn't also speed up 50 times, which is obviously biologically impossible, all that extra output just becomes useless inventory. It's just a traffic jam of unread PDF sitting on a manager's hard drive.
This gets to the heart of how agentic AI fundamentally alters the nature of a knowledge worker's day. It's moved them from sequential execution to parallel execution.
The paper spends a lot of time on this shift to parallel execution. From what I gather, it's kind of the difference between navigating a single-lane drive-through and suddenly being asked to manage a 10-lane toll booth.
That's a great way to put it. In a traditional sequential workday, you finish task A, you close the window, and you open the next window to start task B. Your attention is singular.
You're doing one thing at a time.
But in an agentic environment, because you are delegating rather than executing, you can spin up multiple concurrent workflows. A single worker might instruct Agent 1 to run a compliance check on a new vendor, then instruct Agent 2 to draft a quarterly performance update, and instruct Agent 3 to scrape competitor pricing data.
All at the same time.
All three agents are operating simultaneously, completely asynchronously.
So one person isn't just doing their job, they are conducting an orchestra of digital workers, which sounds incredibly powerful, but also mentally exhausting.
The cognitive load is immense. It shifts from doing the work to tracking multiple moving pieces and verifying them as they complete. You are no longer constrained by your typing speed. You are constrained by your cognitive bandwidth to manage parallel workflows without dropping the ball.
And this dynamic demands a total redesign of team structures and individual skill sets. The skills that made you highly valued as an individual contributor, like meticulous execution, speed of output, deep familiarity with specific software interfaces, they are being commoditized.
Because the systems are taking over the execution.
Exactly. And this brings us to one of the most profound shifts detailed in this deep dive, which directly impacts the career trajectory of everyone listening right now. What actually happens to human expertise in a world where the machines do the executing?
It's a scary thought for a lot of people. But the locus of human contribution, where we actually add value to our employers, is moving up the stack.
It's no longer about being the fastest coder or the most meticulous spreadsheet formatter.
Right, the value is shifting toward higher order activities. Defining the specific objectives for the AI, selecting the appropriate agentic tools for the job, monitoring the agent's progress, and integrating the final results into a human context.
And this leads to what researchers like Tambay and Hitzig identify as the expertise paradox. I love this part. You might intuitively assume that if an AI system is doing all the actual work of writing the legal contract or compiling the Python code, that human expertise in law or computer science would become less important.
Right, you'd think you just need a generalist who knows how to prompt the machine well.
But the research indicates the exact opposite is happening. Deep human domain expertise is becoming significantly more valuable as routine execution is automated. I want to really unpack the mechanics of why this is true because it seems counterintuitive at first glance.
It all comes down to the asynchronous, multi-step nature of agentic workflows. When you use a conversational AI to draft a single paragraph, evaluating that output is trivial.
Yeah, you just read it.
You read the paragraph, you immediately spot a clunky sentence, you fix it, and you move on. The feedback loop is instant and entirely transparent.
But if I tell an agentic system to take 10 years of messy customer sales data, clean it, restructure it, build a predictive model for churn, and generate a strategy document,
The AI goes away for an hour and comes back with a polished final product.
and the intermediate steps are totally opaque.
Exactly. And this is where the expertise paradox snaps into focus. How do you know the AI didn't make a subtle, fatal logical error in step 3 of that 50-step data processing pipeline?
Right, maybe it didn't make a syntax error that breaks the code, but it made a semantic error that fundamentally misunderstands the business context of a specific data column.
I wouldn't know. A generalist wouldn't know. The final presentation would look beautiful and confident, but the underlying math would be poison.
You would only catch that error if you were a deeply experienced data scientist who has a cultivated gut feel for what the churn numbers should look like.
Exactly. Someone who knows exactly which edge cases to stress test the model against. The human domain expert is no longer doing the routine math. They are the ultimate quality assurance safety net.
They are the only mechanism an organization has to ensure that the autonomous systems aren't confidently hallucinating a catastrophic business decision. The expert provides the verification that the AI's methodology is valid across novel edge cases that the training data may not have adequately covered.
So essentially, knowledge workers are being transformed into managers. Even if you don't have a single human direct report on your org chart, your daily function is managerial.
You are managing a fleet of AI agents, you are assigning work, evaluating output, and taking responsibility for the final product.
And this transition from individual contributor to workflow supervisor is a seismic event for the labor market. The Westover paper cites research by Chen et al., which analyzes this shift through the economic lenses of automation versus augmentation.
Understanding this distinction is vital for anyone trying to navigate their career right now. Let's break down the mechanics of automation versus augmentation in this specific agentic context, because they sound similar, but they lead to radically different outcomes for workers.
Automation occurs when the AI entirely substitutes for human labor. In roles that are heavily exposed to pure automation, where the human was primarily engaged in repetitive, predictable execution without the need for complex contextual judgment, we are seeing a decrease in labor demand and the lowering of the required skill threshold for the remaining jobs.
Because the AI replaces the role entirely since the output doesn't require deep verification.
The machine just does it, and nobody needs to double-check the math because the parameters are so narrow.
However, in jobs exposed to augmentation, where the AI's execution capabilities complement and actively rely on human judgment, strategic direction, and a complex verification, the economic effect completely flips.
We are seeing increasing demand for these workers and a sharp rise in the skill complexity required to actually do the job. The market places a massive premium on humans who can effectively collaborate with, supervise, and stress test these advanced systems at scale.
This is a moment for a serious professional self-audit for our listeners. Looking closely at your current role and your daily deliverables, are you positioning yourself as the executor, the person whose primary value to the company is simply getting through the routine task list efficiently?
Or are you actively positioning yourself as the verifier, the workflow architect, the domain expert who understands the foundational logic of the business well enough to catch the AI when it inevitably stumbles?
The economic data Shen et al. Present is quite clear here. The path of the executor leads to obsolescence and wage compression. The path of the verifier leads to increased leverage and value.
Is the strategic imperative of this decade for every knowledge worker. But recognizing this imperative at an individual level is really only half the battle.
Right, organizations themselves have to figure out how to restructure their entire operations to survive this transition. It's very easy to theorize about redesigning workflows, but the operational reality of doing it inside a complex enterprise is daunting.
It's incredibly messy.
Fortunately, the sources we are looking at don't just leave us with abstract theories. Westover's paper aggregates a remarkably detailed, evidence-based playbook. It gives us 5 specific strategies that frontier organizations are using to successfully integrate agentic AI without breaking their companies in the process.
And we are going to spend significant time walking through the mechanics of each of these 5 strategies, looking at the real corporate case studies, because this is where the rubber meets the road for modern management.
Moving from abstract potential to structural implementation is definitely the hardest phase of technological diffusion. So let's look at the first strategy the paper outlines. It addresses the very real danger of trying to do too much, too fast. It focuses on the necessity of a staged rollout coupled with deep infrastructure investment.
Which means resisting the urge to just buy an enterprise license for an agentic AI platform and immediately giving access to all 10,000 employees on a Monday morning.
Which so many companies want to do. But the data we reviewed earlier about organizational friction plays directly into this. You need the technical teams to go first.
The evidence demonstrates that effective enterprise adoption absolutely requires a sequenced deployment. The paper uses Microsoft's internal deployment of their Microsoft 365 Copilot as a primary case study here, drawing on research by Brynjolfsson and Mitchell.
What did Microsoft do?
Well, they did not simply turn the system on for their entire global workforce simultaneously. They aggressively deployed it first to internal technical teams, the engineers, the data architects, the developers. These groups serve as what they call technical champions.
And the reason you need these technical champions isn't just because they are enthusiastic about AI, it's because they possess a high tolerance for technical failure and the skills to actually fix the broken pipes when things go wrong.
Exactly. Let's look at the mechanics of what happens during an early rollout. Say an AI agent is tasked with summarizing an internal project, but the permissions architecture is flawed, and the agent accidentally scrapes confidential HR salary data and includes it in the summary.
Oh, wow. That's bad. If a marketing manager experiences that, they might panic, abandon the tool entirely, and tell their whole department the system is a massive liability.
The organizational trust would be broken immediately.
Instantly.
But when a software engineer experiences that exact same permissions failure, they don't panic. They view it as a bug. They trace the API call, they identify the flaw in the access control lists, they rewrite the security protocol to firewall the HR data, and they push a fix to the infrastructure.
By intentionally letting the technical teams break the system, discover the edge cases, and refine the security guardrails, the company ensures that when the technology is finally scaled to the broader, non-technical workforce, the user experience is stable, secure, and largely frictionless.
It's like letting the builders stress test the house before you let the guests move in.
It makes perfect sense. Okay, once that infrastructure is stable, the organization can move to the next phase, which the playbook identifies as actively redesigning workflows around the concept of delegation.
This goes back to our factory analogy. You have to tear out the steam engine belts. You cannot simply map agentic AI onto legacy processes.
The paper cites a 2024 analysis from The Economist detailing how Klarna, the financial services company, handled this. If Klarna had just taken their new agentic AI capabilities and slapped them onto the front of their existing customer service system, they would have created a disaster.
Let's walk through why that would fail.
Sure. So in a traditional customer service setup, a human agent receives a chat, looks up the customer's account, checks the shipping status, reads the refund policy, and types a response. If Klarna just put an AI in that exact same seat, but didn't change the surrounding architecture,
The AI would likely hit roadblocks on complex issues, get confused, and have to escalate the ticket to a human manager anyway, creating that massive downstream bottleneck we talked about earlier.
precisely the traffic jam at the supervisor's desk.
But instead of doing that, Klarna fundamentally redesigned their entire case routing and escalation architecture. They didn't just ask, how can AI do this one step faster? They asked, which entire branches of this workflow can be cleanly delegated to an autonomous system? And what structural support does that system need to succeed?
Which raises a very practical question for any manager listening right now. How do you actually identify what to delegate? If I am auditing my department's processes, what makes a specific workflow a good candidate for an agentic AI versus a human?
The research outlines very clear criteria for delegability. You are looking for tasks that are well-defined in their scope, highly repeatable, and crucially, easily verifiable.
Verifiable is the key word there.
Yes. If an AI agent processes a routine refund based on a tracking number showing a returned package, a human supervisor can verify that action with a 2-second glance at a dashboard. It's highly verifiable.
But if a task requires nuanced human empathy, like, say, negotiating a payment plan with a distressed customer, or it requires high-stakes moral judgment, or is so complex that verifying the AI's work would take longer than just doing the work yourself, you do not delegate that to an agent.
Klarna mapped their processes against those exact criteria. They built an infrastructure where the AI handled the vast volume of verifiable routine inquiries end-to-end, completely asynchronously, but they simultaneously engineered a robust instant escalation pathway.
So if an inquiry fell outside the defined parameters, it didn't just bounce around an AI loop frustrating the customer. It was immediately routed to a specialized human team, complete with the full context of the AI's initial interaction.
They redesigned the plumbing of the department to support human-machine collaboration, rather than just machine replacement.
They built the factory floor for electricity, not steam. I love that. Now, this brings us to the third strategy in the playbook, and this one is where the organizational friction gets intensely philosophical and incredibly difficult to manage. The strategy is domain expertise development and retention.
This directly tackles the expertise paradox we discussed earlier, where you absolutely need human experts to verify the AI.
Right, and the structural problem here is quite alarming when you map it out over a 5 to 10-year horizon. The paper uses Deloitte, the global consulting firm, as a prime example, drawing on research by Davenport and Middle.
Deloitte recognized a looming crisis in their talent pipeline. In a traditional consulting model, junior analysts fresh out of college spend their first few years doing the foundational grunt work.
They clean massive Excel spreadsheets, they format PowerPoint decks, they manually pull market research, and they crunch the baseline numbers.
And let's be honest, that work is tedious, it's exhausting, and it is exactly the kind of well-defined, verifiable work that agentic AI is perfectly designed to execute instantly.
So on paper, the AI eliminating this grunt work sounds like a massive win for the junior employees. They don't have to stay up until 2 a.m. cleaning data anymore. They can immediately start doing higher-level strategic work.
But that assumption completely ignores how human cognitive development actually functions within a profession.
Yeah.
I mean, how does a senior partner at a consulting firm develop the intuitive ability to look at a complex financial model and instantly know the projections are wrong?
They develop that gut feel and that deep tacit knowledge by spending 3 years manually cleaning the data and building the models cell by cell. The grunt work is the apprenticeship.
Exactly. If the AI does all the foundational execution, the junior consultants never develop the cognitive muscles and the domain expertise required to actually evaluate the AI's output when they eventually become senior managers.
We're basically talking about a scenario where we build an entire generation of managers who look incredibly productive because they have AI agents doing all the work, but they actually have no idea how the underlying business mechanics function.
It's terrifying. If the AI hallucinates a correlation in the data, they won't catch it, because they never learned what the real correlation looks like. They lose the ability to supervise the machine.
So recognizing this, organizations like Deloitte are having to implement intentional friction. The paper explores the necessity of designing apprenticeship models in an AI-augmented setting.
This might mean maintaining certain junior roles or specific project phases where employees are explicitly required to practice core analytical skills manually without agentic assistance, purely for the purpose of skill development.
But let's play this out in reality, because this is where I really have to push back on the corporate strategy a bit.
Okay, let's hear it.
If I'm a 24-year-old junior consultant at a high-pressure firm, and it's 11 p.m. on a Thursday, and I have to present a market analysis the next morning, if the firm tells me I have to do it manually to build my cognitive muscles, I'm going to completely ignore that.
Oh, absolutely.
I am going to secretly use an agentic tool on my personal laptop to do the analysis in 5 minutes, format it to look like I did it manually, and go to sleep. How can an organization possibly enforce manual skill development when the automated shortcut is so profoundly powerful and universally accessible?
You are highlighting the exact vulnerability that keeps chief learning officers awake at night. The enforcement of manual practice in a digital environment is nearly impossible.
Right.
If the incentive structure of the firm purely rewards speed and polished output, junior employees will inevitably rely on the AI, creating a facade of competence.
It's the equivalent of forcing a high school student to learn long division on paper when they have a graphing calculator app on their phone. They will just use the app to get the right answer and write down fake intermediate steps. But with consulting, the stakes are millions of dollars.
Which is why the solution cannot just be a corporate mandate saying don't use AI for this task. The organization has to fundamentally alter how it evaluates junior talent. You cannot assent them just on the final slide deck, because the AI can build a perfect slide deck.
So how do you evaluate them?
You have to evaluate them on their process. You have to institute rigorous oral defenses of their work, forcing them to explain the granular mechanics of the financial models the AI generated. You have to create simulation environments where they are tested on edge case scenarios without AI assistance.
The apprenticeship model has to shift from do this manual labor for 3 years to defend and deconstruct the logic of this AI-generated labor.
Exactly. Organizations have to proactively and aggressively protect the development of human expertise, or they will hollow out their own supervisory capacity from the inside.
That is a massive structural challenge. Okay, moving to the fourth strategy in the playbook. We pivot from preserving human knowledge to managing systemic risk. The strategy is establishing governance and oversight mechanisms. And the risks here are fundamentally different than they were a year ago.
When AI was strictly conversational, governance was relatively straightforward. The primary risk was data leakage. Don't paste proprietary company code or confidential client data into an external public chat prompt.
Right, keep it internal.
But agentic AI operates asynchronously and autonomously. It has the authority to act. It can send emails to clients on your behalf, it can modify shared databases, and it can execute financial transactions. The risk profile expands exponentially.
The paper highlights JP Chase here as the prime example of how to handle this, specifically their implementation of a tiered, risk-based governance framework.
Let's dig into the mechanics of what a tiered framework actually looks like inside a heavily regulated environment like a global bank.
Yeah, please. A tiered framework basically rejects the idea of a one-size-fits-all AI policy.
Exactly. JP Morgan categorizes the deployment of agentic AI based on the potential blast radius of a failure. For example, if a team of internal analysts is using an agentic system to summarize public economic white papers to help draft an internal newsletter, the governance oversight is relatively light.
Because if it messes up, who cares? The risk of the AI hallucinating a detail is low, the output is entirely internal, and an error is easily reversible.
But if an AI agent is proposed for a workflow that touches client money, or feeds data into a live trading algorithm, or generates external regulatory filings, the governance tier shifts dramatically.
In those high-risk tiers, the oversight mechanisms are incredibly heavy. The deployment requires rigorous, multi-stage human approval. The systems must have immutable audit trails, meaning every single digital action the agent takes is logged and traceable. And most importantly, they require automated circuit breakers.
The paper brings up a specific danger here that really illustrates why those circuit breakers are absolutely necessary. It's the concept of cascading errors. Because agentic systems execute multi-step workflows autonomously, often over long periods of time, a small error early in the process can compound into a massive disaster by the end of the process.
Walk me through a scenario of a cascading error.
Consider a weekend scenario. An employee sets up an agentic workflow on Friday afternoon and leaves the office for the weekend. The agent is tasked with pulling specific market data from an external vendor on Saturday morning, running a complex risk assessment model on that data on Sunday, and automatically emailing a strategy recommendation to the firm's top clients on Monday morning at 6 a.m.
The ultimate set it and forget it convenience.
Sounds great, right? But on Saturday morning, the external vendor changes the formatting of their API slightly. The agent pulls the wrong column of data, perhaps pulling raw revenue instead of net profit. It doesn't know it made a mistake, so it feeds that poisoned data into the risk model on Sunday.
Oh no.
The model runs perfectly, mathematically speaking, but based on entirely wrong inputs. By Monday morning, the AI autonomously emails dozens of clients recommending they short a stock they should be buying. The error cascades through the entire asynchronous chain, without a single human ever laying eyes on it.
That is the nightmare scenario. By the time the human logs in on Monday at 9 a.m., the damage is already done, and it's massive.
Which is why tiered governance requires that high-risk autonomous workflows have hard stops built in. The agent can pull the data on Saturday and run the model on Sunday, but the principle of governance dictates that any external client communication must halt and await a manual human verification click on Monday morning before execution.
The governance structures the collaboration to maximize AI efficiency while retaining human accountability for final actions, risk-based rules, audit trails, and circuit breakers. Okay, the fifth and final strategy in the corporate playbook is organizational learning and knowledge transfer, and this ties directly back to how we ensure the entire company benefits from the painful lessons learned by those early adopters.
The paper points to Unilever as the gold standard for this strategy, referencing research by Ransbotham et al. When an organization has tens of thousands of employees, you simply cannot rely on organic, word-of-mouth diffusion of best practices.
Right, if a logistics team in Europe figures out a brilliant way to use agentic AI to optimize supply chain routing, that knowledge does no good if the logistics team in North America is still struggling to get basic API access.
So Unilever established a centralized AI center of excellence. This isn't just a help desk. It's an active hub designed to capture, curate, and distribute organizational knowledge.
Let's look at how this functions mechanically. If I'm a marketing director at Unilever and I want to start using agentic workflows to automate our monthly campaign reporting, I don't have to start from scratch. I don't have to go through the trial and error of figuring out which agents hallucinate the least or what the security protocols are.
Instead, you engage with the Center of Excellence. They have already captured the learnings from pilot programs across all the different business units. They provide you with curated skill libraries. They hand you reusable, pre-vetted workflow templates.
They give you the exact prompt structures and governance guardrails that have already been proven to work within the company's specific IT infrastructure.
They're taking the localized, individual learning of a few tech-savvy employees and institutionalizing it into a formalized capability for the entire enterprise. It drastically lowers the barrier to entry for everyone else.
Setting up these 5 pillars, the staged technical rollouts, the deep workflow redesigns, the intentional retention of human expertise, the tiered governance frameworks, and the centralized knowledge transfer, it all constitutes a robust playbook for surviving the immediate disruption of agentic AI. But the Westover paper pushes beyond immediate survival.
It asks how organizations build for the long game. How do we ensure this technology doesn't just remain a series of isolated high-efficiency projects, but actually integrates into the DNA of the company?
The paper frames this as the transition from episodic use to integration. Episodic use is what most of us are doing right now. It's situational. You have a massive data sorting task and you think, hey, I bet an AI agent could help me with this one specific project this week. You use it, it works, and then you go back to your normal workflow. It's an intervention.
True integration, however, means the agentic AI becomes the invisible default. It is the standard operating procedure deeply embedded into recurring daily workflows. You no longer consciously think about using AI in the same way you no longer consciously think about using the internet when you send an email.
It just becomes the medium through which the work is accomplished. But getting to that level of seamless integration requires a workforce that deeply understands the medium. And this is where the paper introduces the concept of distributed AI literacy.
And I love how the research breaks this down because it clarifies that AI literacy is not a monolith. It's not just sending everyone to a 2-hour seminar on how to write better text prompts. The type of literacy required depends entirely on where you sit in the organizational hierarchy.
The required competencies are highly role-specific. Let's examine the executive suite first. The CEO and the senior vice presidents do not need to know the technical syntax for chaining multiple AI agents together.
What they require is strategic judgment literacy. They must deeply understand the macro capabilities and the hard limitations of these systems.
They need to be immune to both the blind hype of the software vendors and the irrational fear of the doomsayers.
Precisely. They need to make informed capital allocation decisions. They need to understand the economic tension we discussed earlier between using AI to automate away lower-level jobs to save costs versus using it to augment human experts to drive new value.
If the executive layer lacks this specific strategic literacy, they will inevitably mandate the wrong structural changes, optimizing for short-term cost savings while hollowing out the long-term expertise of the firm.
Okay, moving one layer down to the middle managers and department heads, their required literacy profile is completely different. They're the ones actually supervising the transition on the ground.
Managerial AI literacy revolves around evaluation and workflow architecture. How do you accurately set quarterly performance goals for an employee who now commands a fleet of autonomous digital workers?
Right. If a worker's output increases 10x, do you expect 10x more work or do you expect higher quality work? Managers must know how to design the parallel workflows we discussed, how to identify tasks suitable for delegation, and crucially, how to maintain human accountability when the execution of the work is heavily automated.
And then you have the support functions, IT, legal, HR, compliance. Their literacy must be focused on building the guardrails. Which brings us to the final major concept in the research, the necessity of adaptive governance.
And this is vital because the pace of technological change is fundamentally incompatible with traditional corporate policymaking.
If a legal department spends 6 months drafting a highly specific rulebook detailing exactly how employees are allowed to use today's AI agents, by the time the CEO signs the policy, the technology will have completely evolved.
The agents will be capable of multimodal actions and independent reasoning that the policy never even imagined. A rigid rulebook is obsolete before the ink is dry.
This is why Westover heavily emphasizes the shift toward adaptive governance. Organizations must govern based on enduring principles rather than highly specific, rigid rules. Let's clearly define the difference between a rule and a principle in this context because it's the key to making governance actually work over a multi-year horizon.
A rule is tied to a specific technological state. For example, a rule might state, employees are strictly forbidden from using Agent version 4.0 to draft external communications. That rule works today.
But tomorrow, the vendor releases Agent version 5.0, which has been specifically vetted and approved for external communications. The rule is now an active barrier to productivity, requiring a massive bureaucratic review to overturn.
It's brittle. It breaks the moment the environment changes.
A principle, however, is tied to organizational values and risk tolerance, independent of the technology. A principle dictates any autonomous system tasked with generating communications for external clients must include a mandatory human-in-the-loop verification gate prior to transmission, regardless of the underlying software platform.
That principle holds up whether we are using today's AI, next year's AI, or an AI 10 years from now. It defines the required outcome, human accountability for external communication, without micromanaging the specific technical mechanism.
And that adaptive framework allows governance to evolve dynamically as the organization accumulates real-world experience.
If a particular internal workflow, say, using agents to summarize meeting notes, proves consistently safe and highly accurate over a 6-month pilot, the adaptive governance model allows the compliance team to confidently relax the oversight requirements for that specific process.
Conversely, if a new AI capability is introduced that allows agents to autonomously execute financial trades, the governance model instantly triggers the highest tier of oversight. It is a continuous collaborative calibration between the end users discovering new capabilities, the technical experts monitoring the infrastructure, and the governance teams managing the risk profile.
This has been an incredibly dense, multi-layered exploration of how the modern enterprise is physically and culturally rewiring itself.
We have covered an immense amount of ground today, pulling apart Westover's research. Let's synthesize the core journey we've just been on. We began by defining the foundational paradigm shift from conversational AI to agentic AI. We are moving from consulting a digital recipe book to delegating complex asynchronous workflows to a digital sous chef.
We examined the counterintuitive diffusion data, revealing that non-technical departments are often scaling their adoption faster than the engineers, entirely because the technical teams absorb the initial friction of laying the API pipes and building the secure infrastructure.
We confronted the productivity illusion, validating that while an AI can execute specific tasks 50 times faster, true organizational performance is ultimately bottlenecked by the human capacity to review, integrate, and coordinate all that generated output. We are shifting from sequential executors to parallel supervisors.
And through the detailed analysis of the five-part corporate playbook, looking closely at how companies like Microsoft, Klarna, Deloitte, JP Morgan, and Unilever are surviving this transition, we saw the sheer scale of structural change required.
It demands deep workflow redesigns around delegable tasks, the intentional preservation of tacit knowledge, tiered risk management, and the centralized transfer of best practices.
But synthesizing all of this data, all of these historical analogies, and all these corporate case studies, the most critical takeaway for you, the individual listener, is the fundamental shift in how your professional value is calculated in this new economy.
We are rapidly moving away from a labor market that primarily rewards meticulous executors and moving toward a market that places a massive premium on sophisticated supervisors.
If there is one deeply encouraging, stabilizing truth to extract from all this research, it is that your accumulated domain expertise is your single greatest asset in an agentic environment. The autonomous systems can handle the typing, the formatting, the coding, and the endless data sorting.
But it requires a human expert with deep contextual understanding of the business to properly define the complex objectives, to verify the subtle logic of the AI's output, to catch the catastrophic errors in the novel edge cases, and to translate the digital results into real-world strategic action.
Your expertise does not become obsolete when the machines can execute. Your expertise becomes the vital, irreplaceable safety net that allows the entire augmented system to function.
It is the difference between being the person swinging the hammer and being the architect verifying the blueprints. It is a powerful, demanding way to view the future of our careers. But as we wrap up this deep dive, I want to leave you with a final thought to mull over. Something to explore on your own that builds directly on that exact concept of human expertise, specifically circling back to the apprenticeship dilemma that Deloitte is grappling with.
The research clearly, definitively states that we need deep human domain expertise to effectively supervise and verify the work these autonomous AI agents produce.
But if agentic AI inevitably takes over all the routine, foundational execution tasks, the manual grunt work that we have traditionally used to train our entry-level workers and build their tacit knowledge, how does the next generation of workers ever build the deep expertise required to supervise the machines tomorrow?
By aggressively automating away the foundational labor today in the name of efficiency, are we inadvertently pulling up the ladder of expertise behind us?
It is the defining organizational and educational challenge of the next decade, and the answer will determine the long-term sustainability of our knowledge economy.
It really is. A digital sous chef is an absolute miracle during a Friday night dinner rush. But if nobody ever learns how to chop an onion manually, what happens to the restaurant when the head chef eventually retires?
Thank you so much for joining us on this deep dive into the rapidly evolving world of agentic AI. Until next time, keep questioning the workflows around you, keep learning the underlying logic of your field, and keep diving deep.